Nuclear fission is the process of a large nucleus splitting apart to become more stable. A nuclei are made up of protons, shown here with positive signs, and neutrons, shown here without. Fission can happen to large nuclei, which are too big to be held together. And the fission process produces smaller nuclei and also neutrons. But the total number of protons and neutrons doesn't change during this process. So what causes a fission reaction? Well, fission reactions rarely occur spontaneously. All naturally occurring isotopes which spontaneously undergo fission do so shortly into their lifetime. Uranium-235 is an isotope capable of fission, but it can't do it spontaneously. But you don't need to remember which isotopes can and can't undergo fission for your exams, just that in general, it only happens to large nuclei. So fission reactions usually occur when a large nucleus absorbs a neutron. So a neutron must be slow-moving in order to be easily absorbed by the nucleus. And when the neutron meets the nucleus, it is absorbed, and the nucleus gets larger. So why does this cause the nucleus to undergo fission? Well, the neutron makes the nucleus too large to be stable, leading to fission. So the added neutron has increased the atomic mass, creating a new isotope. The nucleus will undergo fission as it's now too big to be held together and it's unstable. But what actually happens during the fission reaction? Well, the nucleus splits into two smaller nuclei, roughly equal in size. These nuclei are large fragments as a result of the uranium splitting. But you aren't expected to be able to predict which elements will be produced after a nucleus undergoes fission. This information will always be given to you in an exam. So what else happens? Well, neutrons and gamma rays are also released. Neutrons are released as there is a difference in mass number between the uranium and the products. Gamma radiation is also released due to the mass difference, but you don't need to know the details of this at GCSE. And here you can see the symbol for gamma. So does this mean the nuclei are now stable? Well, the smaller nuclei typically undergo beta decay to become stable. Remember that during beta decay, a neutron becomes a proton and an electron is released. Following beta decay, nuclei are more stable, as the proton and neutron numbers are now closer together. But you don't need to know what it is about the numbers of protons and neutrons that determines when a nucleus is stable. And there may also be further decays before the nuclei become completely stable. You should be able to explain what nuclear fission is and the steps in its process for your exams.
Thanks for watching. If you want to take your GCSE revision to the next level, head over to launchpadlearning.com and check out our smart learning platform that's been designed to get you top results in your exams. We cover your whole specification and make revision fun with interactive quizzes, easy to follow videos and more. You'll be kept motivated by your own AI tutor who's here to support you every step of the way. To check it out for yourself, click here. Or click here to keep watching a selection of the videos from our full GCSE Physics course. See you there!